So welcome back for the last talk of today. So the last talk of today will be given by Vincenzo De Florio. So Vincenzo De Florio got his PhD at KU Leuven in 2000, has worked in several capacity at KU Leuven and University of Antwerp, received the faculty award from IBM in 2013, and is very it was very active in fractal social organization. But today is going to present us something that I'm very curious about, that it's about generating music using dynamic systems. So I'm very, very curious. I will not go on, and I will give him immediately the stage so that he can show us and actually make us hear. I think it's more important what he does.
Thank you very much for this introduction, and thank you very much to Professor De Koning for inviting me here, and everybody here at BrIAS for this great opportunity. So, what is all about? As I already mentioned, this is an approach for composing music. So this is a talk which is extremely different from the most intimidating lectures that were preceding this one. It's not about science. The science part will be very much reduced. It's more art science, let's say, so very much different. Don't expect great mathematical models out of this. This will be rather elementary, let's say, from that point of view. So what we have here is an approach for generative music, which means algorithmic music. It's totally unrelated to AI. So the attribute generative might lead you to think of generative AI, but it's not. It's music based on for instance, a simulator of a system so based on an algorithm, let's say. So the structure is very simple. I will present my approach, and also I will demonstrate it with some music which I created with it. So the first thing is, okay, dynamical systems. I'm a little bit sorry that we drop from high-level concepts to this level of elementary concepts. But okay, dynamical system, you can see it as a function, a closed function in a set X, which takes, for instance, one input from this set and loops it around. And these kind of points that are like a trajectory in X, it's sometimes called an orbit. So if you take each of these points and you project it into a music space, you get music fragments that you can put together. And so this means that gives an idea why I chose the title of this presentation as Music of the Orbits, because actually it is a sonification of these dynamical system orbits. So an interesting thing for me was that this is fully deterministic, meaning that when you choose a certain function, when you choose the sonification function S also, and when you choose a point in the space of the domain and range of F, everything is decided. So basically, I will show that despite this determinism, I could create some music that, to my taste, let's say, has some interest and provided me with some surprise. Also, I will try to explain the lessons learned up to this point. So it all started with a dynamical system, which I dubbed Heartquake Dynamical System, which the model of which I published on Wolfram's paper, Journal Complex System, some while ago. It is the model of a game called Beggar Thy Neighbor. In Italian, we call it strappacuore. It's played by two opponents with a pack of cards that they have to put on the table. This was taught to me by my wife, for which I'm very grateful. So it is actually I mean, it is not a game in the classical sense. It's more a pastime because it's a choice-free game. Again, like for dynamical systems, you take a pack of cards, you distribute it to the players, and that's it. The game the fates of the game are decided. Despite this, people played this game because the fates of the game fluctuate. It's very difficult to tell beforehand who's going to win. And if you play it very fast, it can be also, I mean, it can give you some heartquake, let's say, and that's why I call it like that. So you just move from one state to the other until you end and you have a winner. A basic question that I and my wife asked ourselves while playing this game was, yeah, okay, but is this configuration already known? Could it be that we ended up in a loop? And okay, I've take a look at the cited paper to have an answer to this kind of questions. But basically, what is a beggar thy neighbor? There is no time now to explain the rules and stuff. But you can think of it as a set of rules that change the ownership of cards between two players that have half a pack of cards each, and they are with the face value unknown, and they uncover one by one. And depending on the rules of the game, there is no time to delve into. The cards that accumulate, that stack onto the table, then can be won by one of the opponents. Okay, I took this, I generalized, I made a simulation, I wrote a program, I made a 3D representation, and blah, blah, blah. What is more important here is, if you have a look from this page of the paper, you have here a dynamical system, which it is the M corresponds to the M in the previous slide. Okay, what you can do when you sonify is that you take the current situation as it is in the hands of the players and on the table. You translate it into integer numbers and then to notes, some way. So you have the original input, the f of the input, the f of the f, and so forth. And then maybe you add some simple rules to define rhythms, like if the note is repeated, notes at step t-1 is equal to the one at t, then you don't play it again like in ribattuto, but you prolong the duration. This introduces rhythm. And finally, there is an aspect which is taking these notes as they are generated in an abstract terms, assign them to instruments, and then finally hearing the results. Okay, if you take these three numbers, numbers like this is 6, 0, and 25, okay, you can consider them also as coordinates, and you can plot them. The interesting thing is that if you take packs, all the possible packs of cards, you divide them into chunks and you plot them, you get pictures like these ones that with a certain, I mean, I didn't theoretically prove that there's a fractal dimension, but I fed them onto a program which told me that 99% it's fractal. It's a fractal dimension. You can see the self-similarity in such pictures. So you can expect maybe something from the sound of this type of system. Now, there's a property which I immediately realized, which is expressed with this strange sentence: genotypical expansion produces phenotypical expansion. What does it mean in practice? When you have pack of cards, and you have here 0, 0, 1, 2, 3, 4, 5, it's a pack of cards. And you have an extension to the pack of cards. So you add, for instance, 0 cards to it. So there is a relation don't like the first is included in the other. Okay, this is like a gene which produces a body, which is the geometrical representation. And the geometrical representation has the same property. So as the gene is included, also the artifact, the body, is included. So, and something like this occurs also in music. So this is useful if you want to prolong the sound of something to intervene in the generation process. Okay, you can do also other things. I played a lot with this kind of things. One of the things that I did is if I have, instead of a pack of cards, a community of responders to a disaster, for instance, and you have I don't know, firefighters and so forth. You can use shapes to define the type of role, and then you can use colors, for instance, to say if the person is activated by the firing condition. There is a car, and this enables a role car driver to get into action. So I did something with the agent-based systems, all based on figures like this one, and I received from IBM a faculty award about this. Okay, this in a sense concludes the boring part. Let me just move to the music itself. So the classical question is, okay, but is it interesting? Yes or no? So I will start, I will let you decide, of course. So I will start with this, which is probably one of the first pieces that I wrote. I chose this one because it's nearly without intervention, purely generative. I mean, at the beginning of my series of experiments, I first gave the word to my simulator, and yeah, okay. Basically, I have here my series of numbers. I partitioned them into three columns representing substates of the system. And so I played a little bit, yeah, for instance, the first track, I only played the first column. It's like a restriction in the orbit. And I assigned them to bassoon and English horn. Then second piece, Kaidan, I did the same, but I added other instruments, and I played also the second column, and so forth. All right, let me see if this sounds plays or not. No, not this one. I want this one. Ah. Why doesn't start? No, doesn't want to start. Maybe I can do like this. Excuse me. If I play here. The graphical representation is the, I told you of two representations, the geometrical and the sound. This picture couples both. I use the Povray light tracer to depict all the matches of this game, and then I moved the observer farther and farther away from a certain position in the scene, and I got this type of representation. Okay. I'll jump to some other parts of the piece because it's 7 minutes. The additional information is given by the second column. Okay. Right. I made a number of experiments. Some were really surprising, some less so. I had presented one. I had presented, for instance, I had prepared one in which, I improvise bass guitar on top of the generated music. But I think the quality of the broadcast system doesn't prevent me to... what I can do is show you this experiment. This is a classical movie, Dadaist movies, a movie of early 20th century. I took it, I reversed all the frames, and I used it as, I matched it to some generative music. And all the combination, all the results are purely incidental. So this is the original. In order to match audio and video, I had to speed up the original movie to 60 frames per second. So there's a number of synchronous moments between the video and the audio that were totally unexpected. Like, for instance, I will cut it short, of course. Like this one. And this was totally unexpected. Okay. And so forth. I have also other music, other experiments which I did, but I think I can cut it short and invite you maybe to have a look at my Bandcamp page where all these experiments are kind of collected. But yes, what I would like now to wrap up and tell you is that, okay, I made a number of experiments. The simplest things, then I shuffled the input, I mutated the input, I made a random generation of seeds, I added special effects, I added guitar, bass, and so forth. One of the strange things, most unexpected things is this kind of conservation law, so that if you apply a little modification to the seeds, sometimes this leads to little modification of the output, and sometimes it does not. This is because of the rules of the game. If I change something crucial, that changes the fates of a phase of the game, then there will be a large modification. So in the end, I have something like a feedback loop. I select a point in a certain space, I sonify it, I assess the quality, and depending whether I'm happy or not, I apply changes, and I move on to a new x0 prime. Okay. Sometimes there's this rule of little modifications in the gene produces little modification in the phenotype, and this can be used, can be perceived as adaptations in the durations, in the notes, and so forth. So this gives a new meaning to the word composer. You compose, for instance, a selection of points and their orbits. So, as I mentioned, this is music from the orbits of dynamical systems. So the thing is, you have everything which is already decided from the moment you have F, the orbiting, the dynamical system, the sonification function, and also the seeds that you select. So you could say that these three elements represents a most compressed representation of the whole music. So if you would talk about entropy, as it was done in the previous talk, the zero entropy is given by this triplet. With that, you can completely reproduce the entire event. So everything springs out from that triplet. And I was very much surprised when I found out that Arnold Schoenberg in 1950 came up with this idea of the Grundgestalt, which is the basic shape, the concept of the basic shape. It tells that in his model, which is actually a generative model of musical production, everything springs out from the team, can be traced back, so like it's the most compressed form. Or put it still more severely, there is nothing but the theme itself. It's like saying a human being, it's all contained in the primeval gene, in a sense, okay. There is much more to it, but in terms of information, let's say. Also, Deleuze wrote something that expresses similar concepts, and many others, like, for instance, Stockhausen with his mantra concept. It's nothing but an initial point that generates everything, like... now, of course, there is also Frank Zappa I'm a little bit addicted to, and he came up with this concept, maybe mutuated from other concepts, the concept of the big note, which says that the entire universe is just a vibration, and it all comes from a single concept. And we are the manifestation of that one seed, which is one note. Yeah, you can find also in Leibniz, in Sikhism. It's not something new. We might have heard of that. So what next? I really would like, provided that BrIAS and Professor De Koning agree, to have an event like a concert for piano, bass, and laptop based on these concepts. And yeah, if you want to know more and to hear more, listen more to this kind of things, you can go and see and visit these things or contacting me. So many thanks. Would you have a question?
Don't know if there are questions or curiosities. Willem?
Thank you.
Yes.
Thank you.
Thanks. That was very enjoyable. So you mentioned you published the original analysis in Stephen Wolfram's journal. And so I remember Stephen Wolfram actually has made these efforts to define classification schemes for discrete
Yes.
time, discrete space, dynamical systems like yours. So you didn't really give us the details of the card game that it is all based on, but can you say something about like what kind of dynamics it shows? It sounds like there is some quasi periodicity in the output, and it goes on for a very long time.
Yeah, there is at some point some periodicity, because in the end you most of the time end in a cycle. So you have to focus on a part. I mean, if the simulator enters a loop, you have to break it. So. But indeed, the work of Wolfram was more systematic. He made a full analysis of all the possible evolutions of his game, let's say. And it would be interesting to sonify that, actually. So, but I don't know anything more than this. You can use this one and then...
That was great. I really enjoyed it. Did you look at dynamical systems which exhibit chaos and maybe compare different sonifications of very close initial conditions?
No. Very interesting question, yes. We did some experiments with other dynamical systems, for instance, based on chemical information, chemical systems organization. I mean, there's a colleague of mine in VUB that is kind of expert on this. So we did some, but they were still deterministic and non-chaotic. So it is certainly something to try. Maybe I should try it with nuclear systems, models of nuclear systems, and see if it explodes or not.
Thanks for a nice talk.
Thank you so much.
I'd be curious to hear about your subjective experiences regarding the control of the system. How much and in what ways can you sort of drive it to some direction you want, and how much do you play with the fact of being surprised by the outputs of the system?
Yeah. From a composer's point of view, I suppose you want to come up always with new things. And this contradicts, in a sense, the need for reapplying rules. But indeed, by playing with the system, for several years actually, I learned a number of rules that I could use to intervene heavily on the process. So from this very first experiment, which I showed you now, the first piece, I went to something that is, I call it hybrid generative, because there is a lot of intervention, a lot. Even the actual files that are produced, the final, let's say, I mean, there is a selection of the initial points, and a modification of the initial points. And you have a number of processes that I conduct at this level, at this stage. Then you get a final MIDI file, in fact. And then the game continued a little bit, and I started playing with the fragments of this MIDI file, modifying them. And so in the end, it is not more pure generative in my, let's say, production. Someone could do maybe a scientific, thoroughly scientific experiment, not intervening at all, trying to use only the machine, like in the first piece, let's say. Or even in that piece, I made some choices, like the columns that I selected. But it was very elementary. So it depends on what you want to do, if you want to go towards the science or towards the art. At some point, I was more inclined to go towards the art.
Okay, thanks.
You're very welcome.
Thank you very much for the fascinating talk.
Thank you.
I have maybe two questions. First of all, is the context of the research that you're leading with this? Like, how did it start, and in what context can you do this? Because I come from more designer artist background, and I didn't know you could do that at a nuclear. You're in a nuclear research center, right?
Yes, but I did not this in that. This was carried out when I was a theoretical computer science researcher at the University of Antwerp, and during my free time. I mean,
Okay. Yeah. That's
So
what I expected, but it's good
I
that.
started playing with this when I was on camping with my wife and playing with my wife, and with on paper and pencil, I was starting writing the simulator or the properties of the system. Then went back and.
Yeah.
And the second question?
So the second question is actually going back to your last comment about like going more through art or science, and also the question of control. Of course, your system is really, you have a really strict and strong boundaries in terms of the notes you're playing, the rigidity of the rhythm, and so on. And at last, you said that maybe someone could try to have no control at all on the system. And I was wondering what you thought about the new, actually, generative AI system that make music, which is more or less this, which is almost completely statistical, and the only control you have on them is the initial prompt.
I'm a little bit against the use of generative AI in music. I use glasses because they help me to see better, and this kind of system compensates for my lack of knowledge as a composer. Let's say it lets me do things, but still I want to be. I want still to do music for music's sake. I like that. So I don't want just a machine that creates something for me and it gives me the authorship of that without. What's the purpose of that? I'm not interested. Thank you. So, but with this, I could. Intervene more and more, let's say. And at that point, I felt that, okay, there were some musical opfers that were handed to me, but I would use them honestly, let's say. I could still say that I'm the author, let's say, of the composer better, in the sense that I mentioned.
Yes. Okay. Thank you very much.
You're welcome. Okay.
There was some. You have some questions? You want to go?
Fine. Did you do? Maybe this has been done, and that confirms my ignorance. And
don't talk about ignorance, please. After your talk.
But did you try to do the opposite? Right, take a piece of music and match it to.
Yes, it's very interesting because the concept of compression that I mentioned is exactly. Yeah, I thought about it. If I could take a piece of music and reconduct it to a finite set of functions and initial points, I would end up with a lossless compressor, which would go exactly in the opposite direction. I thought about it, but I've not been able.
Yeah, but it doesn't have to match it completely. But
no,
maybe you can define a metric.
Then it's not lossless.
That's right. That's right. But it's still.
It's
okay,
exactly like you said that the entropy is zero, or we stop a little bit because for practical reason I don't. I can still use. I found the most practical solution, right? Number of iterations, for instance, as was. You can go for the theoretical perfection, but maybe from a practical point of view, it's much handier to find the one that matches the problem at hand. So to have, for instance, a reduction of dimensions that is usable. Very cool. Thank you.
Okay, so I'd like to thank once more the speaker,